So right here we have a weird sum. Although you can see the pattern right here, we don't exactly know how to do this. Now let's just start by multiplying this out and seeing what we'll get. Plus 1/2 plus 1/6 plus 1/12 plus ... What? We don't even know what the pattern is. We can't see a pattern. If you keep going, you don't really see a pattern. So how are we going to do this? Well, there's something called telescoping sums. And in this video, I'm going to give you an introduction on telescoping sums. And this is one of the most common telescoping sum that you can see. So, what's the trick here? We'll keep watching to find out. So, we see that all of these are in the form 1 over a times a plus 1. So 1 times 2 is 1. 1 times 2, basically. 1 over 1 times 2. And then 1 over 2 times 3, 1 over 3 times 4, and so on. So they're all of the form 1 over a times a plus 1. So how can we turn this into something, for example, of the form a over a minus b over a plus 1? And it turns out that we can actually write it in this form. If we put them under a common denominator, so a times a plus 1 over a times a plus 1 minus b times a over a times a plus 1. So once these are under a common denominator, let's add these together and we'll get this equals a times a plus a minus b times a. And note that I did distribute while I was doing that, and then a plus 1. So right here we see that we can factor our a minus b out, so we get this equals a minus b times a plus a over a times a plus 1. And this is all equal to 1 over a plus, times a plus 1. So we have to find some values a and b such that this is true, and we find that we can just assume that a equals b. So how do we assume that a equals b? Well, nothing tells us that we can't assume that a equals b. And when we assume that a equals b, a bunch of things cancel out. So this becomes a minus a times a plus a all over a times a plus 1. And just saying capital A does not equal a. If you haven't realized already and you're somehow confused, the capital A is not actually equal to the small a. They're different variables. And this ends up being a over a times a plus 1 is equal to 1 over a times a plus 1. And what do we see here? Well, if we multiply the whole thing by a times a plus 1, we're just left with a equals 1. And since we said earlier that a equals b, therefore b also equals 1. So a equals 1 and b equals 1. So this is really important, because if we go all the way back up to what we assumed earlier, that 1 over a times a plus 1 was equal to this right here, and we substitute 1 back in, this is equal to 1 over a minus 1 over a plus 1. And this is true. And if you verify that, it's actually true. So we can make basically a formula. This formula states that 1 over k times k plus 1 is equal to 1 over k minus 1 over k plus 1. And you can go ahead and test this out. You can go ahead and test this out plug in some things, substitute some things, and you'll find that this is actually true. If you actually put these under a common denominator, these two fractions right here, and you put them under a common denominator, you subtract them and do all sorts of manipulations, you'll get this. And what we did right here, this whole process right here, this is known as partial fraction decomposition. And we did it with a very simple case. But if you can try this out on all sorts of different stuff, including stuff like 1 over k times k plus 2. And you can go ahead and try that out. Maybe try to figure out what that is. Now, back to our problem, because we didn't even focus on it for a long time. We were spending most of the time looking at our partial fraction decomposition. But just saying, this right here is general knowledge, so make sure to remember that, because this is not at all important. If you do this every single time during a test, that's not really a good idea. But this is actually pretty easy to remember anyways. So back to our problem. So we see 1 over 1 times 2 plus 1 over 2 times 3, and we rewrite it with our new substitution. So this becomes equal to 1 over 1 minus 1/2 plus 1 over 3 minus, 1 over 2 minus 1 over 3, and then we have plus 1 over 3 minus 1 over 4, and plus, and so on, all the way down to 1 over 100 minus 1 over 101. And guess what? We have something called a telescoping sum, because these terms all cancel out, except for these all cancel out, and so on, all the way down to this 1 over, and the only terms that don't cancel out are 1 over 1 and negative 1 over 101. So after doing all this work, we finally end with 1 over 1 minus 1 over 101, which is equal to 100 over 101. And we are done. So, thanks for watching. I hope you enjoyed. Make sure to check out my other videos on not AMC8, but I do have AMC8 videos too, so be sure to check those out. And I will be adding more stuff on telescoping sums, as this is just an introduction. Thanks for watching.